Today we're going to talk about how to find the lateral area, surface area, and volume of a pyramid. So if you look at this first example here, I have a square pyramid. Now it doesn't look square, but I did say that it was square, so we're going to go with it. Square pyramid, of course, means that the base is a square, so we'll have to keep that in mind when we find different parts of it that we need. Here you'll see that we have a height of 4. And the reason I know that this right here is the height of the pyramid is because it drops right to the middle of the base. So when you go from the peak to the middle of the base, then that's the height of the pyramid. This other dashed line you see here, it goes from the peak to the edge of the base, so that's the slant height. So when we go from the peak to the middle of the base, dropping straight down, that's the height. And when we go from the peak to the edge of the base, that's the slant height. You'll notice that I have a triangle. If I drew an imaginary line right here connecting this edge of the base to the middle of the base, again I'd have that height of 4 with that imaginary line here, and then the slant height of 5. So that's going to make a triangle. You'll see that I drew a triangle over here. I did this because I need the length of the side. The reason I need this side is because this piece right here is part of the base, and in order to find the lateral area, surface area, and volume of the base, I need the perimeter, because P stands for perimeter, which means I need all parts of the base. So again, I have to draw this triangle to find the missing part of the triangle, and then that gives me the length of the base here. So again, this is the height because it drops from the peak down to the middle of the base, and the slant height is from the peak to the edge of the base. And I can imagine drawing a line right here connecting the two parts, and that's where this triangle comes about. Now this triangle is going to be S over 2. The reason it's S over 2 is because again this height drops to the middle of the base, so it cuts it directly in half, and so in order to get the full length I'll have to divide this length by 2, and then that way S will actually give us the whole length. So if you look, I've got a triangle here, so I just used Pythagorean theorem, 5 squared equals 4 squared plus, in parentheses, S over 2 squared. 5 squared is 25, 4 squared is 16, and S divided by 2 squared, you have to distribute that 2 onto both parts, so that would be S squared over 4. Then once you do all that math, you get S is 6. And so now if I plug this 6 in right here, 6 divided by 2 would be 3, so this little piece, the imaginary line, is 3. And again, since that drops to the middle, if I double that, I would get 6, which is what my answer was. So that's why we have to remember to cut this in half when we draw the triangle, because the triangle in our pyramid, again, only takes up half of the length of the base down here. So since the triangle only takes up half of it, this bottom piece is only half. Now we know our slant height is 5, because again you go from the peak to the edge of the base, and then our height is 4, because we go from the peak to the middle of the base. Once I have all that, I can find my perimeter and the area of the base. Again, I have a square pyramid, so if I know that one side is 6, that means all sides are 6. So add that up, I get 24 inches. The area of the base, again, is a square, so I'll just take length times width, or side squared. 6 squared is 36, and then once I do that, I can plug it in to my lateral area, surface area, and volume formula and get all 3 parts. Let's do another one. Number 2 here, this is a rectangular pyramid. Let's zoom in a little bit. This rectangular pyramid, if you look at it, we need the slant height, as I noted here. And how I know that is because, again, from the peak to the middle of the base, that's my height. And I know what the length of my base is, but I'm missing the slant height, which is the peak to the edge of the base. So again, if I pretended to draw a line from the peak to the edge of the base here, you would get that imaginary triangle again, just like we did in the previous problem. So I drew this triangle here. My height is 15, but I cut the bottom piece in half. Remember from the previous example that we said that the side was S divided by 2, because again the height drops from the peak to the middle of it. So I had to take the whole length and divide it by 2. So if this whole length going back is 18, because I'm going back, I would draw this line going back, remember, then that means that that side is 9. Here, let me draw my line right here. This line would be going back, so it's along the 18 here, so that part is 9. And then I would drop that slant height right there. What I had to do here to get L was the Pythagorean theorem, so I'd take 15 squared plus 9 squared, that's going to equal L squared. Square root L, you get 17.49, and then we know that our height is 15 because of our picture here. After that, I can find my perimeter. Again, we have a rectangular base, so I'm just going to add up all the sides. 24, 24, 18, 18 makes 84. And then the area of the base is length times width, so 24 times 18 is 432. And then to get the lateral area, surface area, and volume, we just plug those into our formula. Let me zoom out a bit. Plug those in, and those are your answers. We'll do another one. Let me just flip my paper over. Last one. So this example here, number 4, again, this is a rectangular pyramid. If you look in our rectangular pyramid, we have the slant height right here. That's my slant height, and I know that's my slant height because it goes from the peak to the edge of the base. And when it does that, that's the slant height. I know that going back, this is 10, and this is 12 going this way. So I need the height, which is from the peak to the middle of the base. You'll notice that my triangle is facing a different direction. So it's going to be cutting this way, so that imaginary line is going to go horizontally. It's going to go left and right, and not back. So that means I'm going to cut the 12 in half to get 6. So when I draw my triangle, I have 6 here. And this should be a 15, actually. So if that's a 15, 15 squared is going to equal 6 squared plus 8 squared. So that means H is going to be 13.7. So I need to change that number a little bit. But H would be 13.7. Now that I have all the missing pieces of my height of 13.7, my slant height of 15, and I know that my bases here are 12 and 10, I can get the perimeter. So I add up all the sides of the base to get 44. The area of the base is going to be 12 times 10, which is 120. And then from there, all you do is plug it in to get your lateral area, surface area, and volume.